Hello, my name is Ashley Eckhoff, and I work for the Additive Manufacturing Program at Siemens Digital Industries Software. Today I'd like to talk to you a little bit about how our software can be used to design molds with conformal cooling channels. And along the way, we'll also talk about how our software interfaces with HBD hardware. Before we talk about designing printed molds, we should talk briefly about the molding process. Here we see a chart showing roughly the stages of the molding process, including injection, packing, discharge, cooling, and resetting of the mold. What you will notice is that the time one cycle of the mold takes is dominated by the cooling time. This is where conformal cooling channels normally come into play. So as we work with our customers in the field, we are increasingly coming across companies who are turning to additive manufacturing for the production of molds. And one such company is Toolcraft. Toolcraft is a manufacturing service provider in Germany who uses metal laser melting, robotics, injection molding, mold making, and more to produce a wide range of parts for their own customers in the medical, aerospace, automotive, consumer products, and semiconductor industries. As Toolcraft's additive business has expanded, and as they have transitioned from prototyping to production parts, the profitability of the technology has hinged more and more on the efficiency of the process. Now, back in 2018, Toolcraft won a contract to produce a lighter and more energy-efficient mold tool for a customer. And they also needed to produce that tool faster than was realistically possible using conventional manufacturing. Now, Toolcraft was an early adopter of additive manufacturing, and they decided to use this new technology in order to meet the goals of this project. Toolcraft had already begun using our NX additive manufacturing software for design optimization, build preparation, and print management, but here they took this one step further. At the time, NX did not have built-in functions for conformal cooling design, so Toolcraft used SimCenter to optimize and analyze a manual conformal cooling design. The results were a 30% faster cycle time by massively reducing the amount of time necessary to cool the mold. If you remember the chart I showed earlier, the cool down time takes the majority of the time in a mold cycle. This means that it is ripe for finding new areas of efficiency. Now, Toolcraft was also able to cut some of the mass of the mold almost in half, which significantly reduced the energy consumption of the mold process by utilizing other advantages of additive manufacturing like lightweighting. And by leveraging a single software environment for their additive manufacturing operation, Toolcraft was able to squeeze the inefficiencies out of the process. They convinced their customer that printed mold tools could meet their stringent quality demands, and they made additive manufacturing one of the high growth parts of their business. So let's go look now at how a mold with conformal cooling channels might be designed and printed using the latest version of Siemens NX. So I'm not going to take us through the entire mold design process because it is very involved, but it is worth stating that we have a product inside of our NX CAD CAM CAE solution called Mold Wizard, which allows you to easily design all of the working parts of an injection mold system. If we drill down a bit here and have a look at the actual mold surface, we can see how easy it is to make changes to the final mold design using the strong CAD tools that are built into the NX product. Having a full suite of design tools integrated into the same system as the Mold Wizard mold design tool means that you can quickly and easily make any necessary design changes, and those will be reflected in downstream processes like the final manufacturing of the mold. Now let's look quickly at the conformal cooling design within Mold Wizard. Here we are taking a 2D sketch of the cooling path, and we are basically forming that onto a surface that is offset a set distance from the mold surface. This gives us consistent cooling throughout the coolant path, and the path can be any shape we desire because the final mold cavity will be 3D printed. Again, using our strong design tools, we can then mirror the conformal path to cover the other half of this symmetrical mold surface. Now that our mold with the associated conformal cooling channels has been designed, we can then use another set of integrated tools to simulate the cooling efficiency. This simulation takes into account the materials used for both the mold and the coolant type. We begin by setting up initial parameters including the path of the coolant derived from the conformal cooling channels, the initial temperatures of both the mold and the coolant, and the flow rate of the coolant through those cooling channels. The system then simulates the thermal transfer and returns to us a heat map, giving us an indication as to the expected efficiency of the coolant system. Finally, once the mold design has been simulated and finalized, we turn to production. Here again, the appropriate tools are integrated into NX. First, we select the appropriate printer from a list of printers available to us, and this will define certain printer parameters, including the size of the build tray. We can then place the part in the build volume, and we can assign any necessary support structures. These can be used to separate the part from the build tray, but can also be used to manage the thermal stress caused by the printing process. NX includes a library of built-in support types, but also the ability to use the full set of integrated CAD tools to design and automate the creation of custom support structure types. The additive build is completed by printing directly to a wide range of hardware via various printer interfaces. This often means that there is no need to generate intermediate data formats like STLs, but rather that the print geometry can be handed directly to the printer for the most efficient processing possible. Finally, many, if not most, printed parts require some form of post-print processing. Here, the integrated CAM solution in NX comes into play, where the printed part can be machined to obtain the exacting tolerances required by an injection mold process. CAM in NX allows you to program and simulate the necessary machining steps, as well as interface with quality control systems like coordinate measuring machines or 3D scanning tools. As you can see here, the NX solution set has everything you need to efficiently design, print, and process injection mold tools with internal conformal cooling channels. From the initial design to the final printed part, the process is integrated and efficient. So now that we've seen the basics of the workflow for design, simulation, and printing of molds with conformal cooling in NX, I'd like to talk briefly about our partnership with HBD. You may have noticed during the demonstration video that we do interface directly with HBD hardware. Once your printer build processor is installed, you can select the HBD printers you have installed from the drop-down, and then set the printer build options all from within NX. The printer code is generated and can be sent directly to the HBD printer so that you never have to use any external files or file conversions. This not only streamlines the print process, but it also means there's less chance for error. You always know you're printing the correct version of a part with the correct setup because it's been sent straight from the integrated build setup tools in NX directly to the printer. It's only with strong partnerships with companies like HBD that this type of direct integration is possible. Now we've talked about a lot of steps in the printed mold design and manufacturing workflow, but there are other steps in the overall workflow that I didn't touch on today. Things like managing orders that come into your print shop, scheduling the execution of those orders, and monitoring your factory. Now, Siemens also has software products for managing those steps of the end-to-end additive manufacturing workflow. Now, your particular needs may not require the breadth of the Siemens solution, but the beauty of having a system like Siemens provides is the ability to choose those parts of the system that you need today, with the understanding that you can grow into using the entire end-to-end workflow as your additive manufacturing operation grows. If you have any questions about those other steps of the additive manufacturing workflow or any of the steps shown here today concerning printing of molds and design of conformal cooling channels, please don't hesitate to contact us at Siemens. I hope our discussion about software for design, simulation, and printing of molds with conformal cooling has been useful to you. And I'd like to thank HBD for the opportunity to talk about additive manufacturing software today. And I'd like to thank all of you for spending your time with us. Thank you.